All right, this is going to be page 14 of math analysis. We're still in notes 2, talking right triangle trig. And now we have come to the time where we're going to talk about the special right triangles. So special right triangles, hopefully you've encountered them somewhere, right? So we got 45, 45, 90, which is an isosceles right triangle. We got 30, 60, 90, which is like the most important of the right triangles. So let's see if we know the ratios. So typically for this one, you would say x, x, and then what's the missing side? The missing side then would be x root 2, which you could actually solve for. My radical is crazy there. Uh-oh. Have I forgotten how to make radicals? X root 2. Whatever, we're just going to go with it, right? So these go together. X, x, x root 2. Now, sometimes you might find it useful to kind of rework that, right? So typically you would say it's like x colon x root 2. It's also possible to think, well, this is x, and if that's x, then this would be x over root 2, and this would also be x over root 2. So let me highlight that in a different color to show that it's a different thing. But basically, you just kind of, divide everything in z by root 2, and it works. You could multiply everything in z by 12, and it would work. It's just that this version is equally useful if you know the hypotenuse and you don't know the sides. That's basically what you're going to end up doing. So then 30, 60, 90 is, I think, probably the most important of them. So the side opposite 30 is the smallest side. And then the side opposite 60 is x root 3. And then this is going to be 2x. So, I mean, we could go through and you start with an isosceles, equilateral triangle, and then use the isosceles triangle theorem. You bisect the vertex angle, and then you can just like right triangle your way through it, and you will, or Pythagorean theorem, I guess, your way through it, and you will get these values. Well, you'll get something like these ratios. It depends on how you start. If you start with the side of your equilateral triangle as 2x, you will get exactly these. If you start with x, you'll get half of everything. So you get like the hypotenuse is x, and then x over 2 is opposite 30, and then x root 3 over 2 is opposite 60. It's kind of weird that way, though. So I'm going to say that this is x root 3 and 2x. Okay, so these are our ratios. And now what we want to do, we're just going to use them a couple of times, maybe a lot of times. Triangle ABC to answer the following. So ABC, I got to remember what's what. So I'm actually just going to copy it down. There, I guess. There. This is not a right triangle, but it should have been. So x root 2, and then where's A? This is A, this is C, so this must be B. All right, so if I know BC is a leg, so BC and AC are the same, and then this should be 3 root 2. Okay, if I know AB, that's the hypotenuse, which means each of the legs is the hypotenuse divided by root 2. So this will be 9 over root 2, 9 over root 2. Okay, what if the hypotenuse is 13 root 2? Well, to get each of the legs, I have to divide that by root 2, so it'll be 13 and 13. If BC is 12 root 6, AC is the same thing, so that'll also be 12 root 6. And then the hypotenuse is 12 root 6 times root 2. So it'll be 12 root 6 times root 2, which is actually, so it's 12 root 12. Root 12 is 2 root 3, so it's actually 24 root 3. 24 root 3. Okay, and then if the hypotenuse is 4 root 3, then each leg is that divided by root 2. But I'm going to rationalize that. I'm going to multiply the top and the bottom by root 2. There's no reason to do that, by the way. You could leave this and be totally fine in life. I'm just going to rationalize it because it's kind of neat. So I'll end up with 2 root 6. And then this will also be 2 root 6. So nothing groundbreaking here, just using the ratios. Hardest part is really knowing, so df, and then I guess e is the other one. So df, this will be e, and then here. Okay, so E, and then this we have to know is our 30. So this is X, 2X, and X root 3. So you gotta like have your picture correct or you're doomed. So if DE is 34, then what's the opposite? So EF, so let me just do this. This is our 90, EF is 30, and this is 60. I think this is gonna help me a lot, actually. Okay, so this should be half of the hypotenuse, and then this root 3. This will just be 9 root 3, and then this will be double that. Okay, so this is the most annoying one. Also, somehow I just like crashed this. Okay, I think that when you have the thing opposite 60, it's just the most annoying because that should be, it's like 17 equals X root 3. Okay, so then the thing opposite 30 will be 17 over root 3 because that's what X is. And then I have to double it and get 34 over root 3. Don't rationalize those. There's really no reason. Nothing will simplify if you do. So like, why do it? So here, I have the side opposite 30. So to get the side opposite 60, I need to multiply by root 3, which is a little weird in this case. I mean, it's not really, but you get 8 root 3 times root 3, which is 8 times 3, so you get 24. And then here, this will be twice 8 root 3, so 16 root 3. Now there's a root 2 involved for some reason. I don't know. That's the hypotenuse. The side opposite 30 rather, is half of that. So this will be 4 root 2. And I got to multiply that by root 3 to get the side opposite 60. So that'll be 4 root 6. And then for the next one, the side opposite 60 is 6 root 6. So to get back to the side opposite 30, I know that, and you can always set this up if you need to. This is X root 3, which means that X is 6 root 6 divided by root 3. If I rationalize that, so like it's actually easier, instead of rationalizing that, how about you factor the numerator into root 2 root 3 over root 3, and then cancel your root 3's here. So we'll get 6 root 2. There's just another way of doing it. But I think it's good to know a lot. And if you haven't picked up on this, I think it's good to know a lot of ways to solve a lot of things, because you never know when one's going to fail. And I've noticed in making these videos that it's usually when I'm talking it through in a second way that I notice that I did it wrong the first way. And that's just invaluable because it means that in the end, I don't have it wrong, usually. Don't promise there are no mistakes in these videos because doing them all by my lonesome, but I think I'm doing all right. So this is just practice with these. We're going to need the ratios in the next video, I think. So make sure you have those down. Make sure you know them in general because you're going to need them on whatever you take, the SAT, the ACT, SAT2s, who knows what you're taking, and just your math classes. They're extremely useful to know. So I hope you have found this helpful. See you in the next video.